Okay, now let's see how we can use two of the most widely used type of measures of spread. It's called the variance and the standard deviation. To do so, let's start with an example. Imagine you have two classes of 20 students each, and they made a mathematics test. For example, the first class had the following result. 3 people made a 3.5, 7 people made 4, 8 people 4.5, 1 person 5, and 1 person 5.5. The second class made slightly different because 1 person made a 1.5, 2 people 2.5, 4 people 3, and then 3 people 4.5, 6 people had 5, and 2 made 5.5, and 2 people made 6. So you can see the distribution is different. We have a lot of people here around the 3.5 and the 4, and here it's more dispersed, it's more spread. We have people near 1.5, 2.5, but also 5.5 and 6. A natural question can occur here. It's which of the two classes performed better on this test? So which one was the best? Okay, to do so we can compute the mean, for example. So if we compute the mean of the first class, it gives 4.25. Okay. The mean of the second class gives 4.25, which is actually the same. But we saw the results are very different. How can we quantify this difference? How can we give information about the dispersion of these results? To do so, what we do first is to compute the deviation, so the difference between every grade and the mean. So this result, we get it when we did, okay, the first grade was 1 minus the median, sorry, not the median, the mean. So 1 minus the mean gives minus 3.25. The second one was the grade 1.5 minus the mean, and it gives minus 2.75, and so on and so on and so on. So every grade, with every grade, we compute the difference with the mean, and we get those deviations. We can do the same for the second class, and we get those results. Now what's interesting is to compute the mean of everything. Okay, in general, in average, how far the grades are from the mean? That's the real question. If we compute it, actually we're gonna have 0, because all the positive values will be compensated by the negative one. So it's useless now to compute the average of all the deviations. That's why we square the deviations. So every deviation we had, so minus 3.25, I put it to the power 2. It gives 10.56. Minus 2.75 to the power 2 gives this. So every deviation, I compute it with the power 2. I square it. I can do the same with the class number 2, and I get those deviations. Like this, all the values are positive, and I can compute in average what's the deviation. So let's compute it. For the first class, so I have 0 people having this deviation, 0 persons having this, 0, 0. I have 3 people having this deviation here, so 3 times this deviation, then plus 7 times these deviations. It's like computing an average. 8 times this, plus 1 times this, plus 1 times this, and everything divided by 20 because it's a number of students. And if we compute, we have 0.2375. We can compute also the average for the class number 2. So one person had a 7.56 dispersion. This one, two people had 3.06 dispersion, and so on and so on. So we compute the average and we get 1.63. So here we can see this value is smaller than this value. So it means, in average, the student in the first class are closer to the average grade compared to this one. So we are now able to quantify, to say, okay, this one is closer to the average grade than this one. That's the definition. So we first have to compute the difference between the grade and the mean. We put it to the power 2, and then we divide by the total number. So we add everything up and we divide by the total number of students. If you compute the mean minus the value, or the value minus the mean, it doesn't change anything since you square it after. And what is the standard deviation? The standard deviation, actually, it's just the square root of the result we got before. So here the variance was 0.23 and the standard deviation, it's the square root of 0.23. That's it. We compute the square root because we had to square everything before. So in the end, to get a better result, we compute the square root. And it's also more significant because if, I don't know, we're talking about some distance in meters, computing the variance means having a result in meters squared. So that's why we also compute the square root like this. We have still a measure in meters. Okay, let's see an example together. We have some numbers, -4, 3, 9, 11, and 17. So the first thing to do is to compute the mean. It's 7.2. Okay. Then for every value, so for -4, for 3, 9, 11, and 17, I compute the difference with the mean. So I do -4 minus 7.2, and I get my result, -11.2. I do the same for 3. 3 minus 7.2 gives -4.2, and so on and so on. And then I square these results. It's called a dispersion. So I square every dispersion here, and I get 125.44 for the first one, and so on and so on. And then I have all these dispersions to the power 2, and I compute the mean of it. So I add everything, and then I divide by the total number of values, so 1, 2, 3, 4, 5. I divide by 5, and I get the variance. And the standard deviation, it's just the square root of the variance. So square root of 51.36, which is 7.167. Let's see an old example we use. So here we have a number of people living in a household. So we have 5 times 1 person living in a house, 9 times 2 people living in the house, 15 times 3 people living in the house, and so on and so on. So we compute the deviation. So the value 1 minus the mean, so we computed the mean before, gives this. So every time the value minus the mean gives this, we put it to the power 2. And don't forget that this deviation here, you have it 5 times. So when you compute the average, the mean of all the square of the deviations, you have to consider 5 times this deviation plus 9 times this one plus 15 times this one plus 10 and so on and so on. That's why we add an extra columns here where we multiply by the number of time we have it, and then we divide by 50 and we get 2.64. And then of course the standard deviation is the square root, so just this. When we have a continuous variable, it's the same, but instead of taking the classes, we take the central values. So the central values, I remind you, it's the value in the middle of each interval. So I have 5, 12.5, and I do the same. I compute the difference between 5 and the mean, and then I put it to the power 2. It gives those numbers. Don't forget I have 48 times this value, so 48 times this, and then I can compute the variance and the standard deviation. There is another way to find the variance is with this formula. So it's first every value to the power 2 and we compute the mean minus the mean that we put that we compute the power 2. There is a demonstration, I won't comment it, but just to let you know that this new formula is preferred to the first. Every time your mean or the average you compute first is not an integer, because it's complicated when you have decimal numbers. Let's see an example with the value -4, 3, 9, 11 and 17. So first I compute the mean of the values here. It's 7.2. Okay. Then I square every value. So -4 to the power 2 gives 16. 3 to the power 2 gives 9. 9 to the power 2 gives 81, and so on. And then I compute the mean of all the value of all the squared value. So this plus this plus this plus this plus this divided by 5 gives this result. So in order to compute the variance, we compute this mean minus the real mean to the power 2, and it gives exactly the same result we got before. When we have a continuous variable, actually it's the same. We take the central values, we square it, and then we compute the average, so the mean of the squares. It gives 510 point something. I know that the normal mean is 21. So when I put it to the power 2 is 441. So the variance is the mean of the squares minus the square of the mean, which gives this.